Hello everyone, welcome back to day 17. Before we start today's topic, let me quickly set the stage for anyone who is completely new here. Teamcenter is software made by Siemens. Big companies like car manufacturers, aerospace companies, defense companies use it to manage all their product data. Think of a company that makes an airplane. That airplane has hundreds of thousands of parts. Every part has drawings, specifications, versions, approvals, and a history of changes. Teamcenter is the system that stores and manages all of that. This category of software is called PLM, Product Lifecycle Management. Teamcenter is not a simple desktop app, it is a large enterprise system. Many people across many departments use it at the same time, like designers, engineers, managers, suppliers. And companies often want to connect Teamcenter with their other systems like SAP or a custom web portal or a mobile app. So the question becomes, how do all these different applications talk to Teamcenter? How do they ask it to create a part, search for a drawing, or approve a document? The answer is SOA, Service Oriented Architecture, and that is exactly what we are learning today. Let's get started. Here is our plan for today. In section 1, we'll see what is SOA. We will start from the scratch with real world analogy. In section 2, we'll see four-tier architecture, how Teamcenter is physically organized. In section 3, we'll see service and operation model, the building blocks of SOA. In section 4, we'll see SOA client bindings, the three ways to connect to Teamcenter. In section 5, we'll see request response lifecycle, what actually happens when you make a call. In section 6, we'll see error handling, how SOA tells you when something goes wrong. In section 7, we'll see the difference and relationship between ITK and SOA. Let's start from the very beginning. Think about a restaurant. The kitchen is in the back. The food, the recipes, the chef, all of that is hidden from you. You, the customer, sit at the table in front. You don't walk into the kitchen and cook your own food. Instead, you use a menu. You pick item number 5, grilled chicken. The waiter takes your order to the kitchen. The kitchen prepares it. The waiter brings it back to your table. Now, apply that to Teamcenter. Teamcenter data, which is all the parts, drawings, versions, approvals, is stored in a database. That database is the kitchen. You, as a developer or as a connected application, are the customer at the table. You are not allowed to go directly into the kitchen and change things yourself. Instead, Teamcenter gives you a menu of services. You call a service like create a new part, search for drawings, approve this document. Teamcenter does the work in the back and it sends you back the result. That menu of services that is called SOA, Service Oriented Architecture. More precisely, SOA is Siemens' official framework that exposes Teamcenter's capabilities as a collection of named, versioned services that you can call over a network. Your application never touches the database. It always goes through the SOA services. Now, one thing worth knowing even at this stage. Teamcenter SOA has two styles of communication. The traditional classic style uses SOAP, which stands for Simple Object Access Protocol. This is the older way used by C++ and Java thick clients. The modern style uses REST over HTTP with JSON, which is what newer web and mobile integrations use. We'll see both when we look at the client bindings. But whether you use SOAP or REST, the same SOA service model applies to both. We'll see four design principles make SOA work well. Let's go through them one by one. Principle number 1, loose coupling. Think about an ATM machine. You walk up, insert your card, press withdraw 500 and money comes out. You don't know and you don't care what happens inside the ATM. The bank could replace all the internal electronics of that ATM tomorrow. As long as the buttons still say the same thing and money still comes out when you press withdraw, your experience is exactly the same. SOA works the same way. Your application calls a service by name, say create items, sends in the required details, and get back the result. How Teamcenter does the actual work inside, which database queries it runs, which internal functions it calls, that is completely hidden from your application. Siemens could change all of that internal code in a new Teamcenter version. Your application would never know because the only thing your application ever sees is the service name, what it sends in, and what comes back. Those three things stay the same. Everything else can change. Principle number two, versioning. Over time, Siemens improves their services, but they can't just change a service and break everyone who is already using it. So every service has a version in its name. For example, Core 2013-05. If Siemens improves a service in 2018, they release Core 2018-02. Your old application keeps calling Core 2013-05 and it still works. You upgrade only when you choose to. This is very important in enterprise environments where upgrades takes months of planning. Principle number 3, type safety. When you call a service, you don't just send a random bunch of text. You send a structured object with defined fields, like a form with labeled boxes, and you get back a structured object too. This means mistakes are caught early and the data is always predictable. There are no surprises about what format the data will be in. Principle number 4, server side logic. All the business rules live on the server. When you call create a part, Teamcenter checks the naming rules, checks who has permission, triggers any approval workflows. All of that happens on the server. Your application just says, please create this part and gets back the result. You don't have to code the business rules yourself. Now let's understand how Teamcenter is physically set up. This is called the four-tier architecture. The word tier means a layer. Think of it like floors in a building. Each floor has a specific job and you can only go from one floor to the one directly below it. You cannot skip the floors. Let me walk you through all four floors from top to bottom. Tier 1, the client tier. This is you, the user or the application. This is the software that a person uses or the application that connects to Teamcenter. For example, the Teamcenter Rich Client, which is the desktop application engineers use, or Active Workspace, which is a modern web-based browser interface, or a custom application your company built, or an external system like SAP. All of this sit in Tier 1. The critical rule here is Tier 1 can only talk to Teamcenter by making SOA service calls. It cannot directly reach the database. Tier 2, the web application tier. This is the reception desk. When your application in Tier 1 makes a service call, it doesn't go directly to the main server. It first goes to the web application tier. This is a web server, Apache HTTPD and Apache Tomcat running on a separate machine. Its job is to receive the incoming calls, check that you have a valid session, and forward the request to the right Teamcenter server. Think of it like a reception desk in office building. It receives visitors and directs them to the right department. Tier 3, the Teamcenter server tier. This is where the actual work happens. This is the brain of Teamcenter. When a service call arrives here, it looks up what operation you requested, runs all the business logic, talks to the database, and builds up the result to send back to you. This is also where ITK, which we covered in day 16, runs. ITK and SOA operations both live in this layer. Tier 4, the database tier. This is the vault where everything is stored. Oracle database or Microsoft SQL Server. This is where every part, every drawing, every version, every user, every permission is stored. And here is the most important rule in the entire architecture. Only the Teamcenter server layer in Tier 3 is allowed to talk to the database. That means the SOA operation logic, ITK API calls, and all business logic runs inside Tier 3. They go to the database. But nothing outside Tier 3 ever touches it directly. Not your application, not the web server, everything that needs data must go through the Teamcenter server. So the complete path of a request is your app in Tier 1, web server in Tier 2, Teamcenter server in Tier 3, database in Tier 4. And the response comes back the same way in reverse. That brings us to the end of day 17. To recap what we covered, SOA is Teamcenter's official service menu. Your application calls named versioned services and never touches the database directly. And the four-tier architecture shows us exactly how a request physically travels: client, web app, Teamcenter server, and database. In day 18, we will build on this foundation and cover the service and operation model, the three ways to connect to Teamcenter as a client, and exactly what happens step by step during a SOA call. Thanks for watching. See you in day 18.